So the next thing we're going to start talking about is solving by factoring. So we spent some time already talking about factoring. Hopefully you guys all understand how to factor. If not, definitely please make sure that you're coming in to talk to me about knowing how to do that, because it does make solving quadratic equations much easier if you are proficient in the factoring process. So if we look by solving by factoring, remember that when we're factoring, our goal is to change some kind of polynomial expression or polynomial equation into a multiplication problem. So the reason that is helpful is something called the zero product property. What the zero product property tells us is that if we have two things being multiplied together, it extends to three things, four things, but if we have two things being multiplied together, say a times b equaling 0, then either a has to be 0 or b has to be 0. If I look at a more concrete example, suppose I have 7a equals 0. Well, since that means 7 times a equals 0, if I asked you to solve this for a, well, what number times 7 has to equal 0? Well, I can either think logically about it or I can divide both sides by 7. Either way, hopefully you come up with the result of a equals 0. If I look at another example similar to this one, what if I have negative 3.5 times b equals 0? Well, again, if I try to solve that for b, either by thinking logically about it or by dividing both sides by negative 3.5, either way I should come up with an answer again of b equals 0. Looking at one more where we extend this process along to what happens if I have more than two things being multiplied together. For example, I have 6 times c times negative 1/2 all equaling 0. Well, again, we have that commutative property that tells us it does not matter what order we multiply in. So I could first multiply the 6 times the negative 1/2, leaving me with negative 3c equals 0. Either way, when I go to solve this, I should end up with c equals 0. Each of these are a basic example of how the zero product property works. Again, if I'm multiplying things together to equal 0, one of those things must be 0. So now, how can I apply this to quadratic equations? Well, if I take a look at this quadratic equation here, if I have x squared minus 5x plus 6 equals 0, right now I have a trinomial. It is quadratic because of the x squared term. I cannot use the zero product property as written because, again, the zero product property only works if I have multiplication, a times b equals 0. Well, how can I change this into a multiplication problem? Well, by factoring. Since it is a trinomial that starts with x squared, I can use my factor sum table. I go through my table of factoring. I notice that there is not a GCF between these three terms. I also notice it is not in the form perfect square subtract perfect square. Because it is in the form ax squared plus bx plus c equals 0, where my a, or my coefficient of my quadratic term is 1, I can, again, like I said, use that factor sum table. So if I look at factors of 6 with a sum of 5 and I ask myself, what are two numbers that multiply to give me 6 and add to give me negative 5? I may have to go through some guess and check, but in the end I should hopefully come up with negative 2 times negative 3 does equal 6. Negative 2 plus negative 3 does equal negative 5. So because it is a coefficient of 1 here, it is just x squared, I do not have to go through that longer factor by grouping process. I can go ahead right away and say that that factors into x subtract 2, x subtract 3 equals 0, bringing the negative 2 in here and the negative 3 down in here. Well, notice what this gives me. This gives me x minus 2 times x minus 3 equals 0. I have this form a times b equals 0, where my a is x minus 2 and my b is x minus 3. Well, then according to the according to the zero product property, that means that either x minus 2 must be 0 or x minus 3 must be 0. So if I set each piece of those equal to 0, x minus 2 equals 0 or x minus 3 equals 0, I now have two very basic linear equations that I know I can solve. Doing that, I can add 2 to this first equation. I can add 3 to the second equation, giving me a solution of either x equals 2 or x equals 3. Now, if I were to plug x equals 2 back into my original equation, I should find out that after combining like terms and simplifying my expression, that I do come up with 0 equals 0. If I then plug 3 in, after working through my order of operations, again, I'm going to come up with 0 equals 0. Another way to look at this is because when I solve a quadratic equation, I am solving for an x-intercept. If I were to use either pencil and paper methods, or I were to use a graphing calculator to graph this equation here, x squared minus 5x plus 6, I should notice that on my x-axis I am going to cross at an x value of 2 and an x value of 3. I would like to go through some more problems with solving by factoring, so if you go on to the next video, I will go through on that, on your note sheet, the following examples there.